Hello everyone. Today we're going to go through the booklet revision and just a quick flash forward. I won't go through all of the how can I explain? I'll miss some topics and then talk about them after because some of them I need to do more research about them because basically but first of all let's talk about laws of indices. I already talked about most of these stuff. However, I just want to crack on with my exam proper again. Even if I have to redo everything, I'll redo it. So basically, the laws of indices make it possible to simplify and solve equations that contain indices. So the number on the top, that's a bit too big. So the number on the top is the indice. I mean, it's more of a power, however, it's just the whole idea, I guess. Using the laws of indices. So basically, there are laws, and I'll explain kind of in a second what I mean, what the book, I guess, means by the laws. So how can I make this? Am I able to make, no? Okay, 1 second. Let me make like this. Aha. Yeah. Now that's more like him. Basically, for example, the multiplication law. Let's say you have two same numbers, right? Or not even a number, it can be anything. The big number is the same, right? They're the same. However, the small ones, they're different. To answer this or find something that is equal to it, the multiplication rule basically says that if these thingies, they are in times, that means that you just add the two numbers together, as you can see here. And there's an example of that. So over here we have x and x. X and x are literally the same thing. 6 and take away 2. So 6 take away 2 equals 4. And this x to the power 4 is the same as this equation. Now the division law. The division law basically says that basically that when it's division and the numbers are the same, right? It only in the laws most of the time. I mean, yeah. The thingies, the laws only work if the big number is the same. So when it's division, these two numbers, they take away from each other. So let's say x and x, right? Two same numbers, 5, 3. That's the powers. 2, because that's what? Negative, right? So after that, we have the powers, the power rule, I guess. So let's say you see something like this, right? What this means is basically these two numbers times together. Over here we have an example. 3 times 5 equals 15. This word, whatever this is, law, basically means that if you see this, or if this is the answer to something or whatever, it basically says that the big number is the same, however the power is a negative. So here's an example of this. If it's a 1, I assume, only if it's a 1. If it's not a 1, it will be something different. However, I assume the idea is the same. I assume, because let's say, what can it be? 5, 2. I mean, if I input this in a calculator, let me check what actually goes into a calculator. What does it equal? 2, 5 to the power of 2. Okay, and it equals 2 over 25. However, if it in a decimal, aha. What if I do 1 over 56? Aha. Well, yeah. Okay. Well, I assume it should be something like 5 to 2. No, probably wouldn't be. Well, that's basically this law. Let's just think of it that in exam they will only have once, yeah? index. The index is basically about the zero. If the power is a zero, that means whatever it is, it equals a one. So I can even do a calc like on this whiteboard, like to the power of zero. Okay, now that is a very why? No, it's not. I think it thought it was what was it called? Yeah, I think it said it thinks it's degrees. How can I do not? Yeah, like this. Let me try to do it more like this. Oh yes, here, 1. See? So yes, whatever it is, if it's a 0 as a power, it will equal 1. After index. Oh, another index. There's 4 indexes. I thought they're all different. Okay. I guess that's just like, the side laws. So if you see this or this, well, basically it means square root. Aha. So here's an example. 16 to the power of 1 over 2, that 1 over 2 equals a half. Half is 0 0.5. And so 16 to the power, squared. And 16 squared is 4. Now this, that's kind of what we talked about here. So 1 over n. Aha. Oh, basically, if you, like, the power itself is only like a number without a power, right? It basically says that it is square root, and whatever is the number here, whatever it is, it will go over here. So here we have an example, 24 to the power of take minus 1 over 3, which equals to square root 27, and that square root is like 2 equals 3, like basically powered by 3. Usually square root is just 2, right? Like, yeah. And then another one, whatever is equal to 1, so if it's a 1, then it's equal to the same, like whatever it is, right? This is equal to this if the power is 1. So, now here we have examples. So simplify the expression, so we have to simplify this. Okay, let's try to do it alone. Okay, how am I supposed to take it? Okay, just imagine this is not here, right? So let's just see what laws we can see. Okay, over here, first of all, we can see that it's going to be this and this. No, 2, I assume. Like, there's this. What law is this actually? I'm trying to not to look. Okay, but I already did look. Okay, basically the answer was that this is equal 1.5. And after that, okay, yeah, I'm just gonna look because I genuinely don't know. I don't know why I'm acting like I know. Okay, so this is equal to 1.5, and these numbers, they equal the same because they don't have nothing special with it. After that, they moved the A, like they combined, group-like terms, yeah, group-like terms. And after that, they added these. Yeah, that is logical because when they're near each other, that means times in. So yeah, that's the first law that we took on the top. This law, multiplication law, because when they're near each other, that means they are times in. Oh, let me just get this thing on. Oh, please don't fall. Okay. Oh, wow. Yep. After that, they basically moved. So if it's a takeaway, let me see if there's they don't really have an example of this. Oof, that's bad, isn't it? So over here it's 0.5, which is as we know, it's a square root. Over here we talked about that. So it's going to be square root a. No, it's going to be it's going to be a fraction, first of all, because there's minuses, and when a power is minus, it's a fraction. So the a is going to be like square rooted because of the like 0.5. The b, however, is a good question. Well, the only thing that I can think of it is why it's here is because it's a negative. So, and the 1 is here because it has to be a 1. Like, you can't have like something on the top but not bottom. Like, you can't have something on the bottom without having the top. Don't make it weird. Anyway, simplify the expression. Now this looks much more scarier. I'm just gonna go straight ahead and just start, think like, what's it called? Using this because, yeah, I just have to understand it already. So, make all the indices decimals. Aha, that's what it is. So over here, this would be 0.5. And after nothing else. Oh, over here, you see, over here they have minus b, even though the b here doesn't. They did -1 because I think that is what it is. If something is negative, then it will equal to a fraction and whatever is going to be here. To make the power positive also, because when you move it up, it goes positive. Basically, yeah. Aha, now they grouped the like terms. Aha. They did the thingy-majiggy, like adding them. After that, oh yes, see, because it's a positive one, it's on the top. And when it was a negative, now it's a positive when it moved down. And over here, since it's 1.5, aha, whenever there's a half involved, I guess they'll just do this. Aha, got you. Consider alternate ways to express the simplified expressions. Basically, always have to think of the maximum way of using. Now here we have questions. I do have to prepare answers. I mean, they are at the back of the book, but like I try to do them on my own. However, okay, so over here we know that this is equal to 1 because wherever is a 0 is a 1. Over here it is was it? So it's basically 1/4, but why? Let's kind of try to think, why is it 1/4? So what this basically says is a negative. Oh, 1/2. 1/2 equals a half. So the 16 is square rooted. And since it's a negative, the 4 is like this, right? So that's why it equals 1/4. Yes, got you. Because 1 over square rooted 16 equals 1/4. Yes. That's what it is. Now this. This seems like what we had last time. So 1.5. Is it? No, it doesn't have a hole. Let me check what. Aha. Now this is, yep. Okay, no, it equals 0.666667. Okay, well, the answer is 16, but why is it 16? Let's try to figure it out. So first of all, what I can say is that it's going to be, is it going to be a fraction? No, it's not. Maybe. Well, look, 64 divided by 16 equals 4. How is this a 4? Because, Aha. So basically, where did it say that? Oh yes, over here. You see this thing where we moved the 3 over here. Basically, what they did this time is so they did a square root, put it to 364, and the 2 was left out here as like it kind of should, because they just moved there, and there's like condes here, and this equals 4 to the power of 2, so 16. I get that. Now I don't get this one, so let me ask ChatGPT again. Since it's a negative, they made it positive by just having like the thing. They basically could. They what's it called? They made it. Oh, when you exchange, like basically they made it equal, I guess, if you can say that, by just switching the roles, I guess. Maybe. So yeah, that's for these ones. After that, here, these ones. So, first of all, express as power of x. So what this says is that we have to have the x as what is the power. So, first of all, there's a square root, so there should be a 2. However, since it's in general a square root, that means that the 2 was not a normal 2, it was a 1 over 2. After that, we see like a and b times in each other, so in brackets a plus b. And yes, although there's 2 x's, we just put it as 1 because same kind of thing. So that's the answer. There are many laws here used, however, that's just, yeah. And then over here, this is quite simple. In general, you could kind of do this on a calculator, but so we understand it, I assume this would be like 9 powered by 3 times, what's it called? 9 1 over 6, and then adding these would give, let's see what actually answers. 3. That is the answer that I have in my notes. But I'm just trying to understand how would they do it, like evaluate. So basically, I mean, I guess this is the evaluation. However, when you times them, these add. So would it be 9 1 over 9? No, it wouldn't be. What would it be then? I kind of forgot kind of how to add. Oh, what's called? The numbers. 1 over, no, that's 3. 1 over here. 1 over 6. Aha, so look. Oh, so how can I go back? Stand. Aha. So 1 over 3 plus 1 over 6, that is equal to 1 over 2. Aha. And 1 over 2 is equal to square root. So 9 square rooted, and 9 square rooted equals 3. And the way this equals 2 is because there's 2 2's in a 6. However, that doesn't quite make... Oh, I guess when you do the this type of stuff, they just what's it called? They like divide. That plus becomes a divide, I guess. However, I'm not really sure. However, this is done for this thing. We answered all the questions. Now let's go on a different thing. Here. Let's go. Okay. So, logarithms. Logarithms or logs are a way of writing facts about powers. Logs. These two statements mean the same thing. So, I don't know what just fell. Hopefully, I don't. Hopefully, I don't what. However, so this is the same as this. No, this is the same as this. So, which one? You say log to the base a of b equals x. Aha. So a is log to the base. A is the base, and b is a. There's a word for it, but just b. I guess I just call it big B, and then it equals x. X is the equal one. A is the base of the logarithm, what I just said, and this is basically equal to this. And basically it does make sense because, so what basically logarithms are, it's when like this number is basically powered by the equal one. This is what comes out of this. That's just what basically, yeah. So a times, like, not times, but like powered by x equals b. So here's a thing to remember in order to understand it. The key to being confident in log questions is remember the basic definition. Start at the base, so a, and work in a circle. So a, so when you raise a to the power of x, so you move a, power it by x, and that to get b. That should be pretty straightforward. So after that we have laws of logarithms. So learn these blah blah blah. No, let's just go straight to it. When you plus logarithms, it's basically the same with indices. You can times them if the base is the same, of course, the base. So here we have an example that both bases are 4. So 8 times 2 equals 16, and this is equal to 2. Then when you minus them, it basically means dividing, which again goes back to indices, as when you divide it equals to minus, and it's the opposite way around, of course. So yeah, over here they're dividing them, so it becomes a 3, and then this thing equals this, pardon me. And this is what I just basically said. It's basically the same thing as here, but just the opposite way around. But let's just do it as an example. So let's say we have log 8, and then like the thingy, and then log a thingy. This basically equals to 1/3. Okay, now I don't understand this. Oh no, that's not what it's saying. Aha, I understand. Basically, right now it's basically look, it used to be a positive, right? Now, because they got rid of the fraction, like to make it normal, I guess. I don't know how to explain it. Full, that's the word, full. They made it negative, however, it's still uncomfortable because like when you work out stuff, you want them as positives because like, yeah, positive answer give more trust, but it doesn't matter. And this basically equals this. When you have something like this, so let's say in a question you have like a number raised to the answer, you can move it here, as you can see here. So let's say you have log 5 to the power of 25, 3, you can move it here. So that's what you get after. And then, where did they get 2 from? 3 times 2. Oh, this whole thing, this, without the 3, this equals 2, because 25 to the 25 to the power of 5 equals, no, the opposite way. Or how is it? So 5, how can I say this? So 5 to the power of 2 equals 25. Yeah, that's kind of how, but the opposite way around, how do I say it? I mean, I guess you just have to have your math skills and know that. Or is there a way to know it? Let me think. Oh. Okay, yeah, I can't think of any way. So, let's just go through this and then go at the working example. So, changing the base. You can change the base of the logarithm using this formula. So, let's say we have this, right? We are able to make this. Wait, what? Okay, so here's the example. So at the start we have this, then we get this, and we get this. Oh, this is how you kind of think of it, kind of. So, what timetable? So you know how 3 times 9 is 27. I'm just thinking, is it logical with this part though? How? Okay, I can't find a smart answer. How I see is basically they just kind of like change the base. So how much 9's going to 27? The answer is 3. So could I do that with 25, for example? How much 5's going to 25? So log 525 equals. Nope, I don't want that. Log 525 divided by log 5. Does that make sense? Let me check on my calculator. No, wait, I can check it over here. So, log 525 equals 2. What if log 25 divided by log 5. Yes, but no at the same time. Why is it? Let me do it on my calculator. Log 525 log 525. Oh no, what? 5, not 25. Oh yes, basically this equals 2, so it does work. Aha, I got you. So yeah, it's kind of that logic. I understand it, so you should understand it. This is basically, I already know, but I'll just let you know. So basically, whenever in a question, there's no base. So let's say it's just 50 with our base. The base is 10. That's just a regular, and they're called common logs. And then under notables, x used instead of x, blah 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 blah. And basically, there's a normal log. This equals to log to the power of e. So yeah, if you want to understand it better, go on my logarithm video. I don't know how to put it down below, if I'm honest, but yeah, just go check it out. Just yeah. Now let's go back to the question. This thing. So, the positive value of x, such as log. Okay, so basically, remember what we did? 2 is getting powered by the x. No, opposite x is getting powered by 2 to give us 49, as we can see here. So 7, x equals 7. So now here, 5 to the power of minus 2 equals y. So 5 to the power of minus 2 equals what? I assume it's going to be like, I don't know what it's going to be, but let's just check the answer. Aha, this is what's going to be. So now we have questions. Oh my god, an apple. So the value of y, such as the, okay, basically y, yep. 3, 1 equals 1 over 3. Or does it? Yes, that's what it is. Then this, over here, this one is kind of hard. So basically, since over here as an answer we get this, but we don't know what's p, this is what we do. To find p, we do, how's it called? Square root. We're able to square root 8 by 3, even though it's not minus. However, we're still able to do it just to find p. And let's just try 2. So 2 powered by 3 does actually give 8. So yeah, it does work. After that, the value of log. Oh, you can just do this in a calculator if I'm honest. However, the answer of this is 3 over 1, which is 3. Hold up, yeah. Log 4, 8. No, sorry. 4, 8. 1.5, 3 over 1. I don't know where I got 3 over 1 from. Let me check on my actual calculator though. Log 4, 8. Yeah, in my calculator it says, it said 3 over 2. Yeah, this is equal to this. That is facts. Okay. Express as a single logarithm to the base of 5. So basically what we need to do here is, what's it called? Let me kind of think about it. So we can move the 2 here. So after that we get log a 5 to the power of 2. Let me do it in brackets. After that, we get log a equals 25. No, it's 25. So, after that, let me check the answers. Oh, that is the answer. Yeah, yep, that's the answer, literally. This is the answer. After we have this, these two can just times log, pardon me, 18. This is right. I have my notes, I'm checking them. We move this here, log a 4, 3, take away log a 8. After this, the division, like take away and the division rule, so this is equal to 4, 3 over 8. The reason 8 is in the bottom is because it's a negative. So over here, it's basically this one, the negative. So yeah, and this is right. What just was. Oh, and after, we have another one. Quote. No, why am I pressing? Photos. Wait, is it this one that's after? Yeah, it should be. Let me check. Oh, actually, it's strange. Okay, let's go. Now let's talk about the exponential function. As an exponential function is basically this a to the power of x. How can I make this better quality though? Can I make it smaller? And then, yeah, I don't think that helps much. Well, sorry. The exponential function is basically a to the power of x. Is one where the variability is the power, not the base. So basically, a is not the base. Is kind of the earlier constant form of the expression. Is found in many genetics. Exponential of ever popular. P we represent. Okay, let's just go to the example. So, let's say the question is predict the number of people y. Basically, people are represented as y after 4 years for a population of 500. That's tripling, yeah, every year. Basically 5, 3 because it's tripling and it's happening 4 years. So the years is the power, the how much is the big one, and basically this. And this is what you can use on a calculator. I did read this, however, I didn't quite understand because why is there a graph? Like, me and graphs were not the best. And over here we have an example. So in a production process involving heat transfer, the temperature, this represents the temperature of a mold at the T, which represents time, like minutes, is given by, this is represented by this. Determine the temperature of the mold after 5 minutes. So basically, T over here, that's a T. I can see, I'm not sure if you can. So basically, we just, what's it called? Replace it with a time given, 5. So as you can see here, after that, this, by the way, E is an actual thing on the calculator. So this was equals after, and this was equal to two significant figures. And here's the, what was it called? Questions, which I have answers to on my phone. So let me check. Factorize, is that it? No, yeah, logo. No, is that logo? Yeah, that is it. Okay, basically. I manufacture quadruples. Quadruples is a 4. Think of it as like in games, like double kill, triple kill, quadruple kill. What would they say? So yeah, you have to be a gamer to understand. So this is a 4. It's product of components of 2000. So this is how much we have. Units per year. Oh, so basically they quadruple every year. And after 2000, every year for 3 years. So that's the time, 3. So remember what we did, where is it? How much years and how much time is going to happen for. So we have the how much years, and how, no, yes. No. Oh, yes. Wait, yes or no? Calculate the number of the components produced at the end of 3 years. Aha, here's the number. So ignore this one, that doesn't really matter. So basically, how much it's happening for, and how much it's happening for, or am I 4 years, tripling, yeah, so like this, times 2k, and the answer of this is this is the answer. It's in thousand, there's nothing after this. And now this one is a bit more harder, basically. However, I'll try to explain it. Let me just get rid of all of this. The voltage is represented by this VC across a capacitor in a RC circuit is given by this, where T is the time constant and VC is the supply voltage. Determine the value of VC at when the time is equal to T time, when the supply voltage is VC, is equal to this. So basically, let's just substitute in the numbers. So we know that VC equals 4.5 and time equals 5 T's. So there's this T and this T. As you can see over here, that is, so this one is this one. The one on top is this one. However, that doesn't really matter as much. So let's just substitute in the values. VC, that's what we're looking for, equals 4.5 because over here VC comes first. 1, take away E, and then the E we're able to put minus 5 T over T. And since, like, logically, you know how, let's say T equals 2, right? Yeah. Let's say equals 2. So let's put 5 T's. So negative 10 T's over 2. That will equal 0. Oh no. Why did they include 2? It will equal negative 5. So since over here we don't know the number, we basically just assume that's a 1 because there's one of it, so it's 1. if that makes sense. Usually it would be more different. However, since we're here, we have the value with it, which is assume it's a 1. So 5 over 1 is equal, no, minus 5. Minus 5. That's the answer. Apple, I want a refund. Minus 5. So after that, we have 0.5, 1, take away E minus 5. And after that, this part, like E, is equal to 0.000, no, yes, 67. And so after that, we have 4.51 negative 0.0067. And then we like do this thing, which equals to, this whole thing equals to 9.933. So this times this. And so the answer is 4.47 volts. And that's it for today. Thank you. Goodbye.